Hi, Todd Dunn here on January 29, 2018. Today I'm going to continue my do-it-yourself portable solar panel series, and as part of that I'm going to show you what's involved in making a folding 100 watt solar panel out of two 50 watt solar panels. Since I intend to use an MPPT controller that can accept a higher voltage input and step it down to the charging voltage required for a battery, I'm going to wire the two panels in series. The advantage is that while wiring the two panels in series pushes the voltage that's going to be transmitted to the controller up to about 37 volts, it keeps the amperage the same. And the typical amperage for a 50 watt solar panel is in the 2.7 to 2.8 amp range. The big advantage is that it allows us to use relatively small wire to connect the solar panel to the charge controller. And in fact, we can easily go with as much as 60 or 70 feet of 14 gauge wire between the panels and the charge controller without having a significant voltage drop. That would allow you to put the panels 40 or 50 feet away from your RV or van using either, say, duplex number 14 wire like this, or simply buying a 14 gauge extension cord for around $25 or $30 and cutting the ends off and using that as your wire. The advantage of using duplex wire or an extension cord is that you don't have individual wires that you have to tape together or otherwise secure to keep from having a real mess. You just have a single wire that's easy to coil and put away. And also, it's much cheaper than going with heavier gauge cable. If we wired the two panels in parallel, in order to get even 30 feet from the RV, we'd have to go up to at least 12 gauge wire. And if we wanted to go further than 30 feet, we'd have to go to 10 gauge wire. Well, 50 feet of 10 gauge wire is pretty expensive. So by wiring the two panels together in series, we jump the voltage up, keep the amps the same, and that lets us use smaller wire. Okay, now let's go take a look at the panels, and we'll go through what's involved in wiring the panels together in series and also making them into a folding array. Okay, here are the two panels that I'm using as an example for this. These two panels are from different manufacturers, so they're slightly different sizes, but when you do this, you'll buy two panels, it'll be the same, they'll be the same size. These are both 50 watt panels. In order to make this into a folding solar array, what you need to do is buy a couple of hinges. This is a bigger hinge than you need. This is just one I happen to have on hand, but you buy a pair of hinges, you can get suitable ones at the local hardware store for under $5. So what you do is you simply set a hinge at each end like that. Take your drill, which I have here, drill through the 6 holes. While you're drilling through, to avoid damaging the solar panel, you might want to slip a block of wood under there. That'll keep you from drilling through and into the back of the solar panel itself, just through the frame. And then put machine screws through with nuts on the other end. Snug them up. In this case, for this type of hinge, 12 screws and nuts, and you have a folding solar array. Simple as that. You're going to have to drill 12 holes, put 12 screws on, nut them, snug them up, and you have a folding solar array. So that's really easy. The next thing you're going to want to do is connect your panels together in series. So that means you're going to want to go from the negative of one panel, this is the negative wire on this panel, to positive on the other panel. That's positive over there. So you just want to connect those wires together. Now if you buy two panels that have these connectors on them, all you have to do is go across like this and plug them in together. Then the positive wire that you didn't connect on this panel and the negative wire you didn't connect on that panel can be used to simply connect to the charge controller, and you have your two panels connected together in series. It's very simple making that series connection. And when you're ready to put this away, you simply fold it over and you have approximately a 2-foot by 21-inch package to carry that'll weigh about 15 pounds. Much easier to find a place for that size package than it is a 21-inch by 48-inch 100-watt solar panel. But you'll have exactly the same output. Okay, so that's basically what's involved in getting the panels ready. Negative from one panel to positive on the other panel. Might be a little involved, then you want to drill a hole and cut this off. Put a piece of wire on there that'll go through and join it over here, so you'll need two butt connectors. But other than that, it's pretty simple. So, that's it. Very, very easy to do. You need an electric drill, a screwdriver, probably a pair of pliers. Now that you've got your solar panels wired in series and hinges put on them so you can fold them, you need to run your wires from the panels to the charge controller. There's one thing you should do at the very least, and that is install an inline fuse in the positive line between the solar panels and the charge controller. You can use something like this. This is a simple inline fuse. You just use butt connectors to put it into the line. It opens up, an AGC type fuse fits in there. The fuse should be sized to the same amperage as your charge controller. So if you're using a 10 amp charge controller, put a 10 amp fuse in. That will protect your charge controller in the unlikely event that something happens and your solar panels somehow short out and provide much more amperage than you ever thought possible. There is another option, which is kind of what I prefer, and that's to go with something like this. This is a circuit breaker. This particular circuit breaker is a 15 amp circuit breaker that's rated to 66 volts DC, and you want to make sure that if you use a circuit breaker that it has a voltage rating at least as high as the voltage you expect to get from your panels, which if you have two 12 volt panels wired in series, the open circuit voltage would be about 41 volts. So you need a breaker rated to more than 41 volts. This breaker costs about $10 to $15 depending on where you buy it. You can also buy a little panel like this to make it look pretty and mount it. Just fits in there. You have to flip the switch a little, and then there are screws that come with it to go through the front to hold that in place. The advantage of a circuit breaker over a fuse is not just that if it does go into an overcurrent situation, the breaker will open the circuit, but all you have to do is flip the switch to reset the circuit breaker once you've found the problem. The other thing though is that the circuit breaker like this acts as an on-off switch, so that if you need for some reason to disconnect your solar controller from the batteries, you can turn the circuit breaker off and the solar panels are now disconnected from the charge controller electrically. They're not physically disconnected, but you can do that safely once you have turned the circuit breaker to the off position. So this, with the little panel, costs about $30. These panels are expensive, but you can make one, a piece of Lexan or other plastic, You drill appropriate holes in it. This is a little bit over a 9/16 hole. I think it's 19/32 actually. And drill clearance holes for the screws, and you can make your own panel or you can buy one of these. And that provides you with circuit protection and an on-off switch so that you can disconnect the panels from the controller without going to the trouble of unwiring them. So, if you are going to wire your panels in series, as I mentioned, you do want to buy an MPPT controller. The reason is that your panels will be running at a voltage somewhere between 35 and 37 volts when they're under power, and that is higher than the rating for almost all PWM controllers. Furthermore, if your panels are running at, say, 2.8 amps and 36 volts, that gives you approximately 100 watts from your 250 watt panels. With a PWM controller, what it will do is it will couple the panels directly to the battery and will pull the panel voltage down to the battery voltage. So it might pull your panels down from 37 volts to 14 volts, but it won't change the amperage. So 2.7 amps times 14 volts is what? About 25 watts. You'll lose about 75% of your charging power if you stick with a PWM controller. So if you're going to wire your panels in series, you have to buy an MPPT controller. Again, wiring the panels in series, because it raises the voltage without changing the amperage of a single panel, allows you to use relatively small wires, 14 gauge wires for example, and go up to at least a 50-foot run between the panels and the charge controller, which is going to let you move your portable solar array well away from your vehicle if necessary to get it into direct sunlight, which can be quite desirable. I've seen a lot of people with commercially made portable solar setups whose main complaint is, wow, I can't get this far enough from the vehicle to get it into the sun when I park my vehicle under a tree or something. So I need to get an extension cord. Well, unfortunately, just buying a longer cable won't work unless you upgrade the size of the cable on one of those commercial systems. You'll end up with a big voltage drop, which will make your system even less effective at charging your batteries. And as I said, a circuit breaker allows you not only to have circuit protection because of the amperage limit of the circuit breaker, but also provides you with a convenient on-off switch for the circuit so that you can electrically disconnect the panels from the charge controller so that you can work on the system safely. Okay, thanks a lot for watching. If you liked this video, give me a thumbs up. And I'd appreciate a subscription so that you'll find out about my next video, which I believe is going to be hooking this charge controller up to a battery. And this has Bluetooth, so I can see the details of what's going on in a charge controller with the app that you can download for free to connect to this charge controller. And I can also program the charge controller to set the charging voltages exactly the way I want them, which is very nice, because one of the things this kind of charge controller is good for is that since you can program it, you can set it up to charge lithium batteries. Okay, thanks a lot for watching.